Namaskar. Very warm welcome to all the viewers in this live interaction of CIET NCERT. I am Renu Bhatt with you all and you are watching us live on PME Vidya channel, channel number 11. And apart from this channel, you are with us on our YouTube channels as well, that is NCERT official and NCERT PME Vidya class number 11. And dear viewers, as you can see, I am accompanied by our sign language interpreter. Let's meet him. आप हैं निर्भय आपका बहुत बहुत स्वागत है। अपने सभी देखने वालों को हम ये बताना चाहेंगे कुछ ही देर में हमारे साथ हमारी दूसरी इंटरप्रेटर मधु भी ज्वाइन करेंगी और आप सभी को बताना चाहेंगे हम आज इसके सत्र में किस सब्जेक्ट पे बात करने वाले हैं और कौन सी क्लास है हमारी 11th और हम बात करने वाले हैं केमिस्ट्री के स्टूडेंट्स के लिए। आप सभी के लिए हम बहुत ही इंपॉर्टेंट टॉपिक लेकर आए हैं, दैट इज़ हाइड्रोकार्बन्स। और हाइड्रोकार्बन में हम आज जानकारी लेने वाले हैं काफ़ी इंटरेस्टिंग बातों की। तो हाइड्रोकार्बन्स क्या होते हैं, इनकी कौन कौन सी क्लासिफिकेशंस और कैटेगरीज होते हैं, इसमें कौन कौन सी ऐसी और बातें हैं जो आपको जानना ज़रूरी है, आपको बताएंगे हमारे एक्सपर्ट जो हमारे साथ स्टूडियो में मौजूद हैं। तो बिना किसी देरी के आप सभी का परिचय करवाना चाहेंगे उनसे। आप हैं डॉक्टर राजेश कुमार शर्मा, यू आर PhD एंड IIT गेट। वेरी वार्म वेलकम सर, स्वागत है आपका।
थैंक यू।
और सर को 15 साल से अधिक का अनुभव है टीचिंग का। हम इस पूरे अनुभव का हम फ़ायदा लेना चाहेंगे, अपने सभी बच्चों को हम बेनिफिट पहुंचाना चाहेंगे। तो बच्चों, आपको एक काम करना है, आपको हमें कॉल करना है और कॉल के माध्यम से आपके जितने भी डाउट्स हैं, जितनी भी क्वेरीज़ हैं इस चैप्टर में, आपको कहीं पे बात कोई समझ में नहीं आ रही है तो आप अपनी बातें हम तक ज़रूर पहुंचाएं। आप हमें कॉल कर सकते हैं हमारे टेलीफोन नंबर पर जो है 8800440559, या फिर आप करें हमें ईमेल। हमारा ईमेल एड्रेस है dts.class11@cit.nic.in। यूट्यूब चैनल्स पे हैं तो लाइव चैट बॉक्स में जाकर अपना कमेंट ड्रॉप कर सकते हैं। आप जैसे ही अपनी बात वहाँ पे टाइप करेंगे आपकी बात तुरंत हम तक पहुँच जाएगी। सो वी आर वेटिंग फॉर योर पार्टिसिपेशन विद ह्यूज नंबर्स। आप अपनी क्वेरीज़ के साथ, क्वेश्चंस के साथ हमसे जुड़ें। कोई बात आप शेयर करना चाहते हैं, अपना पर्सनल एक्सपीरियंस, तो उनका भी बहुत बहुत स्वागत है। सो विदाउट वेस्टिंग मच ऑफ आवर टाइम्स, लेट्स क्विकली स्टार्ट दिस सेशन। एंड सर राजेश सर, एट द वेरी बिगनिंग ऑफ दिस सेशन वी रियली वांटेड टू नो अबाउट द हाइड्रोकार्बन्स एक्चुअली। तो हाइड्रोकार्बन्स क्या होता है, क्या हम इसके कुछ एग्जाम्पल्स देख सकते हैं, बता सकते हैं आप?
Actually, hydrocarbon is a category of organic compounds in which generally the atoms of carbon and hydrogen, when combined and associate, make chemical bonds. Then the compound forms are called hydrocarbons. We are in this our daily life surrounded with a lot of compounds that is related with the hydrocarbons. These are present in liquid, gaseous and in solid forms like fuels, methane gas, different kind of material, plastic even, that just belong to the category of hydrocarbons.
Okay.
When we talk about the chemical composition, these are made up of carbon hydrogens, including some other small atoms can also be present in these categories of compounds that will provide some chemical strength, some enhance the properties of these kind of carbon compounds. So hydrocarbons like methane, ethane, propane, butanes, gaseous and liquid and solid forms are present of these compounds.
Okay. सो दैट इज़ वॉट हाइड्रोकार्बन आर। और आपको बहुत ही मुझे लगता है कि आसानी से समझ में आया बच्चों। सर आप जानने के बाद हाइड्रोकार्बन्स, हम इसकी कैटेगरीज जानना चाहेंगे। वी रियली वांटेड टू नो अबाउट द कैटेगरीज एंड क्लासिफिकेशंस ऑफ हाइड्रोकार्बन्स। सर प्लीज एक्सप्लेन।
Yeah, when we talk about categories of hydrocarbons, then we can categorize the depends on the bonds present in the particular structure or molecules. So broadly we can classify these hydrocarbons like saturated hydrocarbons and unsaturated hydrocarbons. Saturated hydrocarbons are those in which carbon atom present only in single bond formation, when there is a linkage of carbon, single bond carbon and carbon, that comes in category of saturated hydrocarbons. When multiple bonds are present between these, like that carbon atoms, then it comes in the unsaturation. And third category is there aromatic hydrocarbons. Well-known example is benzene. So we can talk about from the initials actually what are exactly hydrocarbons. So the term hydrocarbon is self-explanatory, which refers to the compounds formed by combination of carbon and hydrogen only. Hydrocarbons have very important role in our daily life. Hydrocarbons are the source of energy and generally colorless and hydrophobic. The word here hydrophobic, it means that the hydrocarbons having less affinity with the water, these having the unlike undissolving property or just going to be repelled from the water molecules. Hydro means water, phobic means repelling kind of properties. So, hydrocarbons generally remain away from the water like solvents. Their odor is usually faint and may be similar to that of gasoline or light fluid. Most of the fuels contain mixture of hydrocarbons like petrol, diesel, kerosene oil, CNG, that is compressed natural gas, LPG, liquefied petroleum gas. We are using this LPG in our daily life, and LNG also, that is liquefied natural gas. Natural gas means the first member of that particular hydrocarbon, that is methane. Hydrocarbons are also used for the manufacture of polymers like polythene, polypropylene, polystyrene, etc. There are different kind of examples including this. We can see the one substance, that is petrol, that is present in our daily life and playing the key role. This compound also comes in the category of unsaturated hydrocarbons. Some different kind of examples we can also look at here, like that natural gas. Natural gas is CNG, that is compressed natural gas, means when the gas comes under the high pressure, then it changes its state and comes into liquid form. Petroleum is a source of also hydrocarbons. When we separate or going to the purification or destructive distillation of petroleums, then we get different products related with the hydrocarbons. Coal is also contain the carbon and hydrogen, along with some different atoms also present there. Now, classification of hydrocarbons. Hydrocarbons are different types. Depending upon the types of carbon-carbon bond present, they can be classified into three main categories: saturated hydrocarbons, unsaturated and aromatic hydrocarbons.
Okay. तो ये तो रहा classification, that was the classification of hydrocarbons and we have three classification categories, right sir?
Yeah.
अब यहाँ पे सर हम इससे डिटेल में आपसे जानना चाहेंगे what is the difference between saturated, unsaturated and aromatic hydrocarbons, sir?
When we talk about there is a presence of single bonding, that comes in the category of saturated hydrocarbons, like methane, ethane comes in the saturated hydrocarbons category. When there is a multiple bonding present in these hydrocarbons, that comes in the category of unsaturated hydrocarbons. So, hydrocarbons can broadly be classified like aliphatic and aromatic hydrocarbons. Aliphatic again saturated, unsaturated and alicyclic. Saturated hydrocarbons are alkanes, generally contain single bond with carbon, 4 bonds of carbon involved in single bonding. When you talk about unsaturated hydrocarbons, that covers to the alkenes and alkynes. It means that in alkenes there will be a double bond between carbon-carbon atom, and in alkynes there will be a triple bond between carbon-carbon atoms. In alicyclic, cycloalkanes are present. Cyclo means cyclic compound. The alkanes, whenever a carbon atom will join and form a cycle, that compounds categorize cycloalkanes, like that cyclopropane, cyclobutane, cyclopentane means ring of 5 pentagon kind of skeleton will form. In hexagon, cyclohexane is also there. So, we can talk about whenever saturated hydrocarbons contains carbon-carbon and carbon-hydrogen single bonds. These are also called alkanes. Example, methane, ethane. If carbon atoms form a closed chain or ring, they are termed as cycloalkanes, as we have taken example like cyclopentane and cyclohexane. Unsaturated hydrocarbons contain carbon-carbon multiple bonds like double bond, triple bond or both. Aromatic hydrocarbons are a special type of cyclic compounds. Example, benzene, one of the famous organic unsaturated category compounds, that is benzene. Here we can look the structure of saturated and unsaturated hydrocarbons. Methane is the first member of alkene series, in which the carbon atom present in the center, and we all know that carbon having atomic number 6 and valency 4, because electronic configuration goes to 2, 4. There are 4 valence electron in the outermost shell of carbon. So its valency will be 4, and it will make single bond with hydrogen. 4 hydrogen will be joined by single bond. That bond is covalent bond. When we talk about unsaturated, that benzene is there having formula C6H6. There is a skeletal form of hexagon of 6 carbon, single bond, double bond present in the alternate fashion. That gives the ring unsaturated kind of these compounds. Now, we have to discuss in details. So, we are going to take the first member, that is alkanes, comes in the category of saturated hydrocarbons. Alkanes are saturated open chain hydrocarbons containing carbon-carbon single bonds. Here we have to focus carbon-carbon single bond. Methane is the first member of this family, also called natural gas. These hydrocarbons are inert under normal conditions as they do not react with acids, bases and other reagents. They were earlier known as paraffins due to their less reactive nature. Means Latin word, that is param means little, affinity affins means affinity. That means the alkanes having a little affinity to react with certain kinds of other things like that acid or bases because of their inert nature. The general formula of alkanes is CnH2n plus 2. It represents any particular homologue when n is given appropriate value. So, we can take some example in this series. As alkanes have general formula CnH2n plus 2, where n is the number of carbon atoms. If we take n is equal to 1, then formula will be C1H2 into 1. In the general formula 2n, n is going to be 1. So, C1H2 into 1 plus 2, that will be CH4, methane molecule will form. If we take n is equal to 2, then formula will be C2H2 into 2 plus 2, that gives C2H6 ethane, both are gases. In similar way, when we take n is equal to 3 or 4, then formula will be C3H8 and C4H10, that is propane and butane respectively. So, in alkanes, tetrahedra are joined together in which carbon single bond carbon and carbon single bond hydrogen bond lengths are approximately 154 pm and 1110 pm respectively. Each carbon atom in alkane is sp3 hybridized, single bond involved in hybridization that goes to generally sp3 4 orbital forming, and its 4 bonding orbitals are directed towards the 4 corners of the regular tetrahedron at an angle of approximate 109 degree 28 minute. So, this is the molecule of methane, in which we can see that it is present in tetrahedral. Geometry of this molecule will be tetrahedral. Carbon involving in sp3 hybridization, and sp3 hybrid orbital of carbon is going to be overlapped with the hydrogen atom at each corner. As sp3 contains 4 orbitals, so 4 hybrid orbitals of carbon will overlap with the 1s orbital of hydrogen, making this molecule tetrahedral. We can also take some bond parameters and bond angles in this molecule, so that approximately when we talk about bond length between carbon and hydrogen, it is going to be there 108.70 pm, and bond angle approximately 109.5 degree like. So, this is the bond length and bond angle between carbon and hydrogen. And one more interesting thing is also here. When we talk about dotted CH bond like that C dot 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 H, this indicates that this hydrogen atom is present below the plane, means we can assume this molecule here in 3D. So, C dotted H bond is below the plane, and C dark bond, that is called solid phase, is above the plane, and normal 2 hydrogens are present on the plane. So, we can assume this molecule in 3D, giving to the tetrahedral geometry to this molecule. Now, one of the most important and Interesting thing is that we have to nominate or give names to the alkanes, that called nomenclature of alkanes. Generally, nomenclature, when we talk about nomenclature, it gives two kind of these categories. One is IUPAC name and second one is common name. So, to make it more clear, we have to discuss some examples here. Just when we talk about, so we are going to take some examples like that. When we talk about nomenclature, so in IUPAC system we will talk about, IUPAC stands for International Union of Pure and Applied Chemistry. International Union of Pure and Applied Chemistry. This is the way at international level, whenever any kind of molecule to be nominated, this body is responsible to give the name of the all kinds of these compounds. So, IUPAC of alkanes, here alk means carbon, ase means single bond. So, we can assume that when carbon is present in single bonding, that give rise to the category of alkanes. First member, that is carbon.
Sir, I would request you to place that board properly, sir.
Okay.
Thank you,
Is that
sir.
proper? So, carbon having 4 bonds joining with the hydrogen, this is CH4, contain 1 carbon, one is called meth, and suffix of alkane is ane. When we talk about IUPAC, each and every organic compound have its suffix and prefixes also, that is according to the priority series of the functional group. So, here suffix of alkane will be ane and number of carbon is 1. So, 1 is called meth plus suffix ane. So, the name of this molecule will be methane. According to IUPAC, this molecule is called methane. In similar way, we can take the examples one more, like 2 carbon atoms is also there. Hydrocarbon is there, so only carbon and hydrogen will come, because hydrocarbon, hydro means hydrogen, carbo means carbon. So, the compound will be made of only carbon and hydrogen. The 2 atoms are there, like 1, 2, eth plus ane, because 2 root word is called eth. So, this molecule will be ethane. We can also take some more examples in which the long carbon chains can also be involved. So, like that, when we talk about like that, take some more kind of bigger example like C, C, C and C, 1, 2, 3, 4. Put the hydrogen, because hydrogen makes single bond. Here CH, H, 1, 2. Carbon makes 4 bond, 1, 2 bond occupied. It's need to join 2 hydrogen only. So, we can draw the structure in simple manner of any molecule. We have to mind the 4 valencies of carbon. In this case, this molecule will be generated. 4 carbon atoms are there and 4 is called bute and ane is the suffix of alkane. So, we can write it here, this is butane. Or more accurately, when put the like N, this is normal kind of butane, N-butane. It means normal, there is no any kind of a branching involved, then we can put the N, that is normal kind of butane. And carbon contain 4, carbon is equal to 4, so we can put the value of N is equal to 4. We can also derive the formula by using general equation, that is CnH2n plus 2, value of N is equal to 4. So, we can write it here C4H2 into 4 plus 2, formula will be C4H10. From the molecular formula, we can draw the structure, or from the structure, we can just calculate the molecular formula. One more example we can take about that, like when talk about like pentane, 5 carbon will be there. I can also make some difference, 1, 2, 3, 4 and 1 is CS3. This is the skeleton. Always whenever we have to draw the structure, we should mind that we have to complete first the skeletal form, remaining hydrogen atoms will come. I know that one bond already been made, so it will be CS3. Here 2 hydrogen atoms, here 3 hydrogen atoms, like that. 1, 2, 3 needs to join 1 hydrogen by covalent bond, H, H and H. Suppose this is the compound and we have to give the name, IUPAC name. So, we have to select the longest chain, as in 11th class in the previous chapter like general organic chemistry, this part already has been discussed in the book. So, in this level we must able to nominate or select the longest carbon chain. Here I have to give numbers to this chain. So, I think about before numbering or starting, I know that this is 1, 2, 3, 4, but from where should I give number 1, like this one or this one? That will decide it the group present here. This group will decide from where we have to start the numbering. So, it should be the methyl which is present here, this is CH3, this is methyl, and the carbon to which this methyl is attached, it should be given minimum number. This is the rule of IUPAC. So, we have to start from here like that 1, 2, from this end I will start I 1, 2, 3, from here it is coming on the third position, from here it is on the second position. I need to give the minimum number to this one. So, I will start from here 1, 2, 3, 4. 2 CH3 is called methyl. So, IUPAC name of this compound will be 2-methyl, how many carbon? 1, 2, 3, 4, butane. So, it can written as 2-methyl butane. IUPAC name of this compound will be 2-methyl butane. Now, we will take some more example like some difficult kind of these are some simple examples. We can also discuss one or more example which having more branches. So, we must have the exactly idea what we are going to write here. So, like that C, 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 again I can make this one also bigger, C, and one is branches here, one branch is here, one branch is here. I have just made this like this one. I can also put some heteroatoms, but we are going to discuss alkanes. So, all the atoms must be carbon and hydrogen. This is CH3, here is also CH3, 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 CH3. Now, I have to check whether all the 4 bonds of carbon are appropriately. Here is 1, 2, 3, it's need to put one hydrogen. So, I will put one hydrogen here. Now, I have to give IUPAC name to this compound. So, should I start this one 1, 2, 2 is CH3, 1, 2, 2 is also CH3, 1, 2, 2 CH3 are there, 1, 2, 3, 4, 1, 2, 3, 4. Now, methyl group present on CH carbon number 2, 2 methyls and carbon number 3 is also. So, name of this compound will be written as 2, 2 because 1, 2 for this methyl and second 2 for this methyl. So, it will be 2, 2 again 3, 3. 3 times methyl has been came. So, I will write here 2, 2, 3 trimethyl 1, 2, 3, 4 butane. So, it can be written as 2, 2, 3 trimethyl butane. Parental chain can be also we can put in box. So, it will be more clear that this is the parental carbon chain and remaining to be known as branch. These branches to be generally put it in alphabetical order, but here only methyl, methyl, methyl is also there. So, can be written simultaneously, but if other groups are coming, then we can put these groups according to their alphabetical order. So, this will be one more example. We can also take like that CH3, one more example. Two branches also here. So, like this is 1, 2, 3. Now, parental chain and group can be like 2 and 2. So, we can write it here 2, 2 dimethyl, 2, 2 dimethyl propane. This will be IUPAC name of this compound and this is a famous situation. So, in common labeling, that is common name, one is IUPAC name, one is common name. So, its common name will be, when talk about its common name will be what? Common name will be neopentane. common name will be neopentane. What is neo? Neo means when one carbon attach with 4 carbon. When one carbon attach with 4 carbon, that condition is called neo, and in this case total carbons to be counted. So, this to be known as neopentane. So, here we have taken examples of IUPAC at this alkene level. So, generally because this portion already has been discussed in the previous chapter, but we must have very clear idea about IUPAC of alkanes, alkenes, alcohols, aldehyde, ketones, carboxylic acids, because in 11th class generally IUPAC given in detail. So, everyone must have some better idea like IUPAC, it plays an important role. Look at in this table, we have certain examples are given here, in which we have discussed like methane, ethane, propane, and third one is 2-methyl propane, pentane is also here, and like 2-methyl butane, and we have discussed this next example, that is 2,2-dimethyl propane or neopentane. So, this is one of the most important part of the hydrocarbon. We must have ability to nominate these kind of compounds. Now, in further.
Okay, so that was about the nomenclature of alkanes. Until now we have learned a lot about hydrocarbons, dear viewers. Hydrocarbons क्या होते हैं, alkanes के बारे में, saturated and saturated and aromatic hydrocarbons के बारे में सर आपने बताया, nomenclature के बारे में आपने बताया. Until now we have learned a lot about hydrocarbons, and dear viewers, it's time for us to move forward. और हम इस discussion को आगे ले जाना चाहेंगे और जानना चाहेंगे isomers और isomerism के बारे में. सर, what exactly are they? Please elaborate.
Yeah. When we talk about isomerism, that is, it means simply isomerism means the molecular formula of the compound must be remain same, but different structures can be written. So that isomerism is the phenomena where 2 or more compounds share the same chemical formula, same atoms, but have different structures or spatial arrangements, leading to distinct physical and chemical properties. All of the alkanes containing 4 or more carbon atoms show structural isomerism, meaning that they are 2 or more different structural forms. For example, butane, pentane, hexane shows different isomers. When we talk about isomerism or isomers in hydrocarbons generally, so to generating any kind of isomers, the compound or must have 4 carbon atoms. Less than 4 carbon atom isomers not to be possible. So, here we have some examples like butane. Already we have just calculated its formula. Its formula is C4H10. So, we will try to explain, we will try to understand how these different structure forms can be generated. So, by taking some example of like butane molecule, this having formula C4H10. What we are doing? We are creating the isomers of these molecules. We are in the part of isomerism. It means that the components must be remain same, but we have to generate different structures of these. So, first structure, that is very normal, CH3, CH2, CH2, CH3. This structure, calculate the number of carbon and hydrogen, 1, 2, 3, 4, C4, and 10 hydrogens also there, 3 or 3, 6, and then 4, 10. Now, I think I should think about how to create the different another structure. So, the carbon must remain 4 and hydrogen must remain 10. So, in this way I have to think about that and I have to just create another structure. So, I can draw the, I can change the structure, I can just change the form of chain 1, 2, 3, 4, carbon 4, write it here, carbon 4, hydrogen CH3, CH3, 6, CH3, 1, 2, 3, 1 hydrogen. Now, count the number of carbon and hydrogen, carbon 4 and hydrogen 3 plus 3 plus 3 plus 1, C4H10. This is the example. Here is what? This is N-butane, or you can simply butane, and here is 1, 2, 3, 2-methyl propane. So, I can say that formula of both these are same, that is the same significant property of isomers. The molecular formula must remain same, but the structures can be written differently. So, skeletal has been changed, the chain has been changed. So, the butane having two isomers, further the possibility of the making different chain in this case is not possible. If we can take some more like that, bigger example, like generally these kind of at 11th level we must able to produce the isomers of butane, pentane, hexane. So, in case of pentane isomers, formula C5H12, this is pentane. So, put one kind of structure, 1 CS3, CS2, CS2, 1, 2, 3, 4, 1, 2, 3, 4, 5. This is the pentane having long chain. So, we can write it here, here is pentane. And now I have to think about another structure of this one. So, I should change the connectivity of carbon atoms. Here is the chain of 5 carbon atoms. Formula must written here C5H like that 12. 1, 2, 3, 4, 5. 5 carbon atoms. Okay. Remaining put the hydrogen like CH3. Here is 2 hydrogen. We can write it separately. Here is 3 hydrogen, that is CS3. 1, 2, 3, 4. And remaining 3 hydrogen can be written like this. We can also write this one as CS2. Okay, we can also write CS2 here. We can also write CH. So, give the name 1, 2, 3, 4, 2-methyl butane. Count the number of hydrogen atoms, 3 plus 3 plus 3, 9, 10, 11, 12. C5H12. What is the formula of this one? C5H12. What is the formula of this one? C5H12. But structures are different. Structures are different, that is why these are isomers of pentane. Now, think about more. Can we draw another structure? The molecular formula must remain same. So, in this case, one structure can also be possible. Make the skeleton 1, 2, 3, 4, 5, that is neopentane or 2,2-dimethyl butane. Put it CS3, 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 CS3. Now, 1, 2, 3, 2,2-dimethyl propane, 2,2-dimethyl propane. Count the number of carbon atoms 1, 2, 3, 4 and 5. It is C5 hydrogen atom 1, 3, 3, 6 or 6, 12. So, C5H12. Now, the one point must be noted here. What? Molecular formula remains same in case of isomers and structures must be different. And one more important thing is there, its IUPAC name must also be different. If the IUPAC name is coming same, then we can't say that the new structure or new isomer has been formed. So, we can say that in case of butane 2 isomers, in case of pentane 3 isomers are possible. One more example that is generally asked in case of like hexane. When we talk about hexane, what possibilities of creating the different structures of hexane possible? So, hexane comes like that, C6H14, this is hexane. Now, we have to create or write isomers of hexane. Formula must be C6H14, structure must be different, IUPAC name must be different also. So, these 3 points we have to keep in mind. Now, 1, 2, 3, 4, 5, 6. H CS3 1, 2, 2 hydrogen, 1, 2 attach 2 hydrogen more. Here is all like that. H, 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 H. First structure, put it how many? 6 carbon, 1, 2, 3, 4, 5, 6 hexane. you can write it here, this is hexane. Now think about next structure that comes 6 C6H14, the structure must be different. So I am going to write the like this 1, 2, 3, 4, 5, put one branch, like C. So 1, 2, 3, 4, 5, 6 carbon is also coming, put it hydrogens like CH3, terminal carbon always contains CH3, CH3, 2 hydrogens like put it here CH2, 1, 2, 3, 4, 1, 2, 3, 4, here is 1, 2, 3 like that H. Numbering CH3 closer to this carbon. So CH3 is closer to this carbon, so we have to start the numbering from this carbon. That's why this is 1, 2, 3, 4, 5. So it will be 2 methyl. How many carbons in the chain? 5 pentane. When we count the number of carbon atoms, 6. Number of hydrogen atoms, 14. Now I should check whether the isomers has been formed or not. Yes, exactly, it has been formed because molecular formula coming same and IUPAC names are going to be different. That comes in like that. Now think about the next structure. How we can generate the next another structure which must have the same molecular formula. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Put CH3 in the middle. So terminals always CH3. Here is like CH2, CH3, CH2, CH3, and this is 1, 2, 3. Put it one hydrogen. Now we have to give the IUPAC name. So it will be like 1, 2, 3, 4, 5 and 1 is 6. Total carbon atom 6. Hydrogen will be 14. Its name will be 3 methyl pentane. 3 methyl pentane. So
J.
3 methyl pentane. How many isomers has been generated till yet? 3. Now we are going to play with the structure. Exactly, we should think like that. We are going to play with the molecule, like that. Children's play. How many possibilities are there to do something like that? So here in this case, like C6H14, we are just going to play with the molecule. We are trying to create the different structures. So in this sheet till yet, how many isomers has been we have created? 3 isomers. So now think about the more possibilities, how we can create. So fourth possibility will be there like that. 1, 2, 3, 4, now 5, 6. Always when you try to write the isomer, make the skeleton first. If I compare the previous sheet, there is no branches, that is good. There is one branch at the second position, okay. There is one branch at the third position. So this is different case like that, okay. Now I am thinking to create 2 branches in this molecule. Just compare this one. One branch at different positions, 2 isomers. No branch, third isomers. And now 2 branches. How many carbons are there? Just count 1, 2, 3, 4, 5, 6. Okay, right here C6. Now put out a hydrogen. CH3, 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 CH3. How many needed hydrogen to be added here? Count the bonds only, simple. 1, 2, 3, put one hydrogen. 4. 1, 2, 3, put one hydrogen. 4. Because carbon always make 4 bonds. Now count the number of hydrogen atoms. 3 plus 3, 6. 6 plus 6, 12. 12 plus 2, 14. It means that Formula is satisfied, formula is same. Now, we have to give the IUPAC name to this one. Like start counting 1, 2, 3, 4. So, it will be 2,3 dimethyl butane 1, 2, 3, 4. 2,3 dimethyl butane. Now, I should check whether isomers has been formed or not. It must have different name. What was the first one? Hexane. Now 2-methylpentane. After that 3-methylpentane. And this is 2,2-dimethyl butane. Different names. So, structure isomers fourth has been created. Now, moving to the next possibility to creating the isomers. We can look like that 1, 2, 3, 4. Now, put 2 branches at the 1 carbon. Put 2 branches at the 1 carbon. So, it will be CH3, CH3, here is 1, 2 like that, CH3 and CH3. Count the carbon atoms 1, 2, 3, 4, 5, 6, C6H40. Again, its name will be 1, 2, 3, 4. 2, 2 dimethyl butane. Previously was 2, 3 dimethyl, but it is 2, 2 dimethyl. Position is different, structures different, but molecular formula same. So, in this case we can say that we have created the isomers in case of hexane 5s. 5 isomers are possible in case of hexane. In case of pentane, we have made 3 isomers. In case of butane, we have made in 2 isomers. So, we must know these kind of possibilities. By this way, we can create the isomers. So, it was about the isomers, how we can generate or create the isomers. As we can see here on the screen also, we have created like that in case of butane. Here 2 possibilities of isomers is there. In case of pentane, we can look like that isomers. And in case of hexanes, these are 5 isomers. As we have drawn here, we have made and created and discussed about that. We have also given the IUPAC name to these isomers. So, the next portion will be methods of preparation of haloalkanes. I mean that we are going to discuss about preparation of alkanes.
Okay. तो मेथड्स ऑफ प्रिपरेशन ऑफ एल्केन्स हम जानने वाले हैं. इससे यहाँ पर हम आपसे भी जानना चाहेंगे पहले कि अगर हम हाइड्रोजनेशन की बात करें तो कैन वी हैव सम एग्जांपल्स फॉर दैट?
वी आर जस्ट कमिंग ऑन दिस पोर्शन हाइड्रोजनेशन. So, students, before discussing to this preparation methods, we must have discussed with some basic terminology. Whenever in chemistry it is coming like that. So, we must be very clear with that terminology. If we know the meaning of that term, we can create the reaction. Like that, ma'am has asked that hydrogenation. Hydrogenation means addition of hydrogen. Hydrogenation, just take the word and catch the word. Hydrogenation, addition of hydrogen. Dehydrogenation, removal of hydrogen. Halogenation, addition of halogen. Dehalogenation, removal of hydrogen. Hydration, addition of water. Dehydration, removal of water. Dehydrohalogenation, removal of hydrogen and halogen. These are the terms generally comes in chemistry in different chapters and different examples and different reactions. If we know these terms, we can just understand in better way that the meaning of the particular term indicates what. As ma'am has asked that about hydrogenation, it means that the addition of hydrogen. And addition of hydrogen where? When we talk about preparation of alkanes, then we can generate alkanes from the alkenes and alkynes, because alkene contain double bond and alkyne contains carbon carbon triple bond. In case of alkenes, one is sigma and one is pi bond. In case of alkynes, one is sigma and 2 pi bonds, and pi bond is weaker than the sigma bonds. So, it can be broken easily and addition of hydrogen can be taken place over there. Single bond compound can be converted into, or double bond containing compounds can be converted into single bond containing compounds. Like that, the preparation of alkanes from unsaturated hydrocarbons. As you may ask that the meaning terminology of hydrogenation, that means addition of hydrogen in simple manner.
Okay, fine.
And this method generally used for the preparation of alkanes from the alkenes and alkynes.
So now, could you please explain us and all our viewers, how can we prepare alkane by Woods reaction, sir?
It is coming the next, that Woods reaction is one of the most important pathway to generate alkanes. In this reaction or in this process, we create alkanes from alkyl halides. When alkyl halides just react with the sodium metal in presence of ether solvents, like that, in presence of ether, dry ether generally taken. So sodium atom, just a metal that takes the halogen atoms together, and the formation of carbon-carbon single bonds will take place, leading to the generation of alkanes. So as this method we will discuss like that. The preparation of alkanes in first, like that, from unsaturated hydrocarbons. Dihydrogen gas adds to alkenes and alkynes in the presence of finely divided catalyst, which plays a significant role, like platinum, palladium or nickel to form alkanes. This process is called hydrogenation. These metals also absorb hydrogen gas on their surface, means we are talking about platinum, palladium. These are metal belongs to generally transition series and act as a good catalyst. So in this case, these metals absorb hydrogen on their surfaces and activate the hydrogen-hydrogen bond. Platinum and palladium catalyze the reaction at room temperature, but relatively higher temperature and pressure are required with the nickel catalyst. So generally the hydrogenation can be shown here. There is a R means alkyl, RCH double bond CH, then R, addition of hydrogen from alkenes, double bond carbon, carbon, double bond alkene. Metal can be taken like platinum or palladium or any nickel. So the double bond will change into single bond. RCH2 bond CH2R. Here the one thing to be noted, that CH double bond CH, one bond has been broken. From the H2, one hydrogen has been attached by covalent bonded. So the generation of alkanes taken place. Similar in case of propene, CH3, CH double bond CH2 plus H2, PT or PD in presence of like nickel. What we have to do? Hydrogenation. We have to add the hydrogen where? The reactive sites. So one bond is weaker pi bond. So break this bond, give one hydrogen to each atom, and CH becomes change CH2 and terminal CH2 change into CH3. So in this case, by addition of hydrogenation reaction, we can create alkanes. In the next example, like CH3 CH triple bond C triple bond CH plus 2H2, PT, PD or Ni. Just similar way, one bond break, two hydrogen used, but here two bonds have to be broken, like that alkynes containing two pi bonds. So 4 hydrogen needed for the addition purpose. Hydrogenation will take place stepwise, and we will get the propane again from propine. It can also be asked that how you will convert propine into propane. So simply we can say that by the hydrogenation process, we can change the alkyne first into alkene, and then we will get final results, that is alkane. Second method is also from the alkyl halides, like alkyl halide accept fluorides, which is having some dissimilarity due to high electronegativity. One reduction with zincs and dilute hydrochloric acid gives, that is CH3, CH2, CH2Cl, chloropropane in presence of dilute zinc and dilute HCl. It will be changed into CH3, CH2, CH3. We will get propane from alkyl halides. One of the most important reaction, that is called Woods reaction. Alkyl halides on treatment with sodium metal in dry ethereal solution gives higher alkanes. This reaction is known as Woods reaction. and is used for the preparation of higher alkanes containing even number of carbon atoms. It may unsymmetrical also. An alkyl halide on Wood's reaction leads to the formation of symmetrical alkane having an even number of carbon atoms. Two different alkyl halides on Wood's reaction give all possible alkanes. So, Wood's reaction can be shown here. The reaction of two molecules of alkyl halides dissolve in dry ether. We can look at here Rx, R is alkyl methyl ethyl, sodium metal Na, again another molecule of X, R. So, the NaX, twice of NaX molecule will just move out and R, single bond R will be created. So, the formation of alkanes will be done by using this kind of Wood's reaction. We can prepare symmetrical alkanes like CH3Br, methyl bromide reacting with sodium metal, BrCH3 another molecule, 2NaBr to be given out, and we will get CH3 bond CH3, that is ethane. Here methyl bromide can be converted into ethane. In case of unsymmetrical alkanes, take it as CH3Br and BrC2H5, twice of NaBr will be given and we will get propane. So, this is about Wood's reaction. We can also talk about carboxylic acids, that we can prepare alkanes from the carboxylic acids, derivatives, salts of carboxylic acids by the process of decarboxylation. It means that removal of carbon dioxide. D means out, carboxy, carbon and oxygen, decarboxylation. Sodium salts of carboxylic acid on heating with soda lime, mixture of sodium hydroxide and calcium oxide, gives alkane containing one carbon atom less than the carboxylic acid. This process of elimination of carbon dioxide from a carboxylic acid is called decarboxylation. We can look at here about reaction of decarboxylation, which preparing to alkanes. Like that RCOONA, this is a sodium alkanoate, sodium carboxylate reacting with the base in presence of CaO, heating, triangle indicates heating, in presence of calcium oxide we will get alkanes, that is RH, and Na2CO3, sodium carbonate will be given out. R can be taken as example CH3, so this is a sodium ethanoate reacting in similar manner with NaOH, that giving methane plus Na2CO3. In case of sodium propanoate, again reacting with the base NaOH, reaction conditions will be same and we will get the ethane. Sodium propanoate contain how many carbons? 3, but ethane contain 2 carbons. So, by decarboxylation we will get 1 carbon less alkane than the parental compound, because 1 carbon to be lost in form of carbonation. So, till yet we have discussed about alkanes, like that hydrocarbons, different categories of hydrocarbons we have classified, like that saturated, unsaturated and aromatic kind of hydrocarbons we have discussed. We have taken example of benzene, that is aromatic, and one of the most important famous kind of this molecule is there. Unsaturated alkenes, alkynes, and especially alkenes we have taken different examples. We have classified, we have gone to the generating formulas, we have discussed about the general formula of alkanes, that was CnH2n plus 2. We have created different examples. We have discussed about preparation methods of alkanes by taking different examples. We have created isomers also and we have discussed about that.
So, we have discussed a lot about hydrocarbons basically, dear viewers, and definitely we will discuss later on this on our another session, right sir?
Yeah.
And before, as we are reaching at the end of this session and we are running very short of time, we have to wrap up this session here only. But before that, let me thank our expert. Thank you so very much Rajesh sir for being here. and for your precious time and for this very easy explanation about hydrocarbons. I'm quite sure, dear viewers, this session would be very beneficial for all of you. यहाँ पर हम मधु आपको भी धन्यवाद करते हैं और इस सेशन को हम यहाँ पर समाप्त करना चाहेंगे और यहाँ पर अपने सभी देखने वालों को ये कहना चाहेंगे कि हम आपके लिए बहुत जल्द अपने दूसरे लाइव इंटरेक्शन के साथ हाजिर होंगे जो कि बायोलॉजी के 12th स्टैंडर्ड स्टूडेंट्स के लिए रहेगा और हमारा टॉपिक रहेगा रिप्रोडक्टिव हेल्थ. सो बी विद अस ऑन PME Vidya channels for more interesting programs. Me, Renu Bhatt, is taking your leave, but you stay tuned to PME Vidya channels. Thank you.